Hi everyone, so we're gonna talk about numerical extension of Rutherford's model. And I just studied it like yesterday, and whatever I got, like I understood, I'm gonna explain to you. So yeah, it's gonna be helpful for somebody. I will really, I will be really happy to know that. So first of all, this is an atom. Okay, so let us say this is as you know, we describe, like we show that this atom atomic number through z. Okay, so now what can I do is, yeah, so let us say this is the nucleus of an atom. This is the center one. This is the nucleus of the atom. So let me just write it. All right, so this is nucleus of the atom z. Right, so now as you know, the nucleus is always positive, and so let us say it has the charge, let us say this is q1, right, and this is going to be the q2. Alright, so now here the charge over it is positive Ze. To determine that it's the charge of this atom's nucleus, so I wrote Z with the E. Alright, so E means electron, and positive electron charge means that whatever the charge on an electron is, but it's in positive, as you know, protons charge and electrons charge, that is equal. Alright, so now here we have this is an electron, alright, which is revolving. This is this one. Alright, so now here, let me just do this one thing, erase this, and now as you can see, this is an electron. Alright, so this is an electron, and now what is there is some force, right, force being exerted through by this proton. When an electron is revolving in its orbital path, this proton or this nucleon exerts some force, that attractive force on electron, right? So I am denoting this force by Fa. So let us say Fa is nothing but attractive force. Okay, and now you should know that there is some force onto the electron, which is, trying to, this is called the centrifugal force. Let me just show it with Fc. This is centrifugal force. Let me just tell you a little bit about the centrifugal force. Now let us say this is an orbital path, and there is this electron of mass m, and it has some velocity, and this is the radius. Alright, this is the radius. Now there is some force, which is just centrifugal force, Fc. It is mv squared upon r. Right, so when this is revolving around, in the new orbital path, there is some force exerted upon this, which tells it to like move here this side. But this force which is being applied onto this electron, this does not allow this electron to just go and in the effect, in the, how shall I describe it, whatever this is, you can discover about what centrifugal force is. So you can also call it circular force. So there, you just know that there is another force, right, except of one force which is being exerted by the proton onto the electron. All right, there is another force which is called the centrifugal force or the circular force. All right, so here we have like two forces acting upon it. Now what is the problem is that if this force will be greater than the force of this centrifugal force, then electron will just move here inside, and if this will be more, then electron will not be able to revolve in this orbital path. So net force, to make the net force zero, right, we have to show that this force is equal to this force. This can only be possible if this is the condition, when Fc will be equal to Fq. All right, sorry, F8 is, all right. So net force is zero, which means this will be in equilibrium. Equilibrium, equilibrium. It means if the object is in rest, it will stay in rest. If it is in some uniform motion, it will stay in uniform motion. Okay, so now we have to make it equal, Fc and Fa, to just get the net force zero. We have to make sure that these two forces are equal, and just because we are talking about just the magnitudes, I'm going to add here modulus. I guess it's called modulus. I can't recall it right now. I've not just studied more. It's just my beginning. So now we're putting a modulus over this Fa and Fc. So because we're talking about magnitude, just magnitude. All right. Now let's open this Fa. You should know that two charges, they exert force on each other, just like you might have studied about this gravitational force. Let me just say F is equal to G m1 m2 r squared. And just like this, you might have studied in Coulomb's law. If you have not studied about Coulomb's law, you can just definitely watch it. The Coulomb's law, it says that same thing happens with two charges. They exert force on each other, which is represented like this. F is equal to K, Q1, Q2, and R square. R is the radius of that atom. Okay, so now let's write it right inside it. K, Q1, Q2 upon R square equal to, now I just told you about the centrifugal force or the circular force, which is equal to mv square upon R. Are you getting it, what I'm trying to say? Alright, so now as you know, this Q1, let me just show you. Let's try the color. So this Q1, this is the Q1, this is the Q1, and this is the Q2. This is Q1, this is Q2. Let's put them. So it would be like this, Q1, so it is Ze. I told you the charge on this is Ze on the Q1, right? So it's multiplied, and along with this one, electron is having a charge of negative E, and upon R square. Now as you can see, we can just cancel it like this. Okay, so it will be R, just R. Alright, and then we have mv square. Now we can just do it like this. Now this is negative, it will come outside, it will be K Ze E R equal to mv square. Now we can just remove the modulus, whatever this is. Alright, so it will be like this, Ze square, okay, upon R equal to mv square. Now we're gonna multiply both the sides by 2, half, sorry, multiply both sides by half. Now it would be like this. Let me just erase it. Now how will it be? It will be half and K Ze square upon R equal to half mv square. Now as we know that this is nothing but kinetic energy. This is the formula for kinetic energy. So now kinetic energy is equal to half mv square, and these are equal, so you can write it like this also, Ze square upon R. So yeah, you've got like another formula for kinetic energy. Right, so here what it is, Z is the atomic number, like it can be gold, it can be silver, atomic number, and E stands for electron, which is 1.6 into 10 to the power minus 19 coulombs, the charge on electron, but in positive. Right, and then K is a constant, which is 9 into 10 to the power 9 Newton meter square, coulomb minus 2, and R is the radius of the electron. And now what I mean by radius of electron is the distance between the electron and its proton, the nucleus of the atom of electron. Right, so this is how we get this. And one more thing to tell you. Now we got this formula, and with this formula we'll be finding out about potential energy, we'll be talking about total energy and so on. Right, so now here let us say this is a nucleus Z and there are electrons. Alright, so this is the orbit 1, this is the orbit 2, so this is electron 1, this is electron 2. Now if I'm going to ask you which electron more kinetic energy is there, so now what can you do is use this formula. As you can see, the radius here is lesser than the radius here. Okay, and now as you know, we're gonna increase the radius, it will decrease the kinetic energy, and the less the radius, it will increase the kinetic energy. So we can say it Ke, that is kinetic energy, is proportional upon z upon r, because here E square is constant, then 2 here is constant, K is constant, so these are constant, so we're not talking about that, right? So yeah, here now if you're going to, the less the radius, more the kinetic energy, and the lesser radius is here, so the more kinetic energy, as you can see, will be in electron 1, right, which is nearest to the nucleus of an atom. Now let's talk about potential energy. Okay, so now let us say this is the center of an atom. This is the nucleus. So it has charge plus Ze, and it has charge negative E because it's electron, as you can see, and this is the radius, the distance between those two charges. All right, so now for potential energy, okay, you should know that for potential energy the formula is like this: K Q1 Q2 upon R. This, there is no R squared, this is just R. This is just R. The force I told you about, it is K Q1 Q2 upon R square. But if you're talking about the potential energy, you might study it later on, but this is the formula for potential energy. Right, so now you can just do this one thing, it is put K, right, and what is Q1 here, it is plus Ze, and what is Q2 here, it is negative E, right? You're going to write it like this, and now it will be negative Ze square K upon R. So this is the formula for potential energy. Alright, so this is the formula for potential energy. And what was the formula for kinetic energy? It was positive K Ze square upon 2R. Now what does this negative sign here signifies? It means there is force of attraction. There is force of attraction, and this plus signifies there is repulsion. Alright, there is repulsion and there is this attraction. When you're talking about like on a charge on anything in chemistry, you should know that negative symbolizes attraction and positive symbolizes repulsion. Now let's clear our confusion. So this is the formula for kinetic energy, and this is the formula for potential energy. All right, now let's talk about total energy. Now what do you mean by total energy? It just means you're going to do the sum. It is nothing but just the sum of kinetic energy and potential energy. All right, so what was kinetic energy? It was plus Ze square K upon 2R, and potential energy, it is minus Ze square K upon R. Let's take Ze square K upon R common, so it will be half minus 1. Now let's try to solve it. Ze square K upon R will be 1 minus 2 upon 2, which will be negative Ze square K upon R. This is what you will get. So this is the formula for total energy, which is just the sum of potential energy and kinetic energy. Now type of questions, or what you should know, a relation between them, is we're going to do potential energy upon kinetic energy. Now what was the formula for potential energy? So now let's do this relation, PE, potential energy upon kinetic energy. This will get cancelled by this, and R will be cancelled by this, so you will get minus 2, which is PE upon KE equal to minus 2, which means potential energy is equal to minus 2 times of kinetic energy. So if you just know about kinetic energy, you want to find out potential energy, just multiply it with minus 2. This is the relation between them. And if you're going to do same with potential energy upon total energy, you will get it like this: Ze square upon R. Wait, what it is? Ze square K upon R, 2R minus Ze square K. This will get cancelled by this. This will be this, and you will get plus 2, which will be total energy is equal to you can do it like this: potential energy upon total energy, it will be 2, so it will, potential energy is equal to 2 times of total energy. 2 times of total energy. Now just like this you can find total energy upon kinetic energy, and you will get it. Total energy is equal to minus any negative of kinetic energy. So you should just you can just remember this formula, and the rest you can just remember these relations between them. It would be really easier for you to solve the questions when you're doing this. You are just learning this and memorizing the relation between them. We will be solving questions in our next video, just like 1 or 2 questions. So stay connected, and we'll talk about distance of closest approach in our upcoming videos. Thanks.